Welcome back. In this episode, we finally complete our ultimate ore processing setup. But that's just the start. ZPM needs cutting-edge tech, so it's time for scanning, data sticks, and lots of upgrades. This is Star Technology. Let's get into it. Alright, well, we know the score. I didn't finish this part of the build last episode, and so I'm going to have to fiddle it in here, even though this is being recorded after the next section you're going to see. So just assume that this continues on from when I was doing the ore processing in the last episode. So yeah, seamless. Done a little bit of work over here just in the meantime. So what I've done is I've created the storage wall for all of the purified ores. So that means that it's no longer clogging up the drives in here. We'll just have the dusts, like aluminium dust, iron dust, etc. The things that we're actually going to use in our crafting. And that keeps this a bit cleaner. So I've created this extra thing behind here. Looks a bit messy, but it's behind the scenes now. So I do like how it's sort of integrated with the wall here. I was pretty happy when I thought of that idea. Rather than having them stick out, looks a bit cleaner. Also, I just wanted to show this off. It's called a big pipe door, and it looks pretty cool. The big pipe door, it looks like that. Lantern and copper plates, and the copper plates are made just in the iron table saw with a waxed block of copper. At some point, I managed to spawn a beehive over there somewhere. The bees disappeared, but they had enough honeycomb in them to actually make that waxed block. So that was lucky, I guess. So let's check the clipboard. Build thermal centrifuges to convert the purified ores into refined ores. Well, that's what we need to do. Everything's already set up, so we should probably just get building. Because we've seen this before, just up there, we'll use the terminal, I think. Done. Just need to put in some hatches and things. Control hatch, and maintenance hatch, energy hatch, and now it's happy. And now it's powered. Cool, all right. Thermal centrifuge, that's what we want. Now we want inputs and outputs. It's just 1 and 1, I think. Input bus, output bus, nice and simple. We're going to want some of those modular routers. Modular router on that. Now, how many do we have on this wall? 51. Okay, so does 51 divide into 40 evenly? No, it doesn't. It's going to be about 12 per machine, which means probably we need 2 modular routers for each. Okay, so I guess I'll probably do it like this. Let's configure these, put some stack upgrades in them. I think it's 6 per machine. 6 times 8 is 48, so there'll be a few left over. Actually, some of these we shouldn't be processing through here. So the process of making indium concentrate uses purified sphalerite ore and purified galena ore. So we don't want to process those, we want to keep them as is. It's galena and sphalerite. And of course the platinum line takes purified pentlandite ore, sheldonite ore, bornite ore, and chalcopyrite ore. So we should probably exclude those as well. Chalcopyrite, sheldonite, bornite, pentlandite. So there's 51 different ores here. And if there's 6 that we're not going to be processing, that takes us down to 45. I think that means each of these machines, we need to do 6, because there'll be 8 of these modular routers. Yeah, that works out. So what I'll do is I'll build the other 3 centrifugal units and then just configure them all up and come back. All right, we're done. I've created the other thermal centrifuges, churning away, working nice and fast. And over here, we've got the wall of storage for the refined ores. That means the next step is the maceration. So what are we going to be doing for that? We are going to need to build one of these large maceration towers. Well, 4 of them. So they don't look too hard. That's another 5x5 block, which is pretty good. But that means that it will sit nice and neatly here. And because the outputs from this phase is all dust, we don't need another storage wall. So I'll do what I did before. I'll build one of these by hand, and then the other 3 I'll build using the terminal. Let's clear this out. Let's get started. Cool, that's the main structure of it. Let's put the controller block in. Maintenance hatch, parallel control hatch, energy hatch, last ingredient, which is the crushing wheels. Done. Okay, that's it, that's built. We'll set up something similar to what we've got here. One in, one out. Put that in there. Put that in there. So we need a modular router. Put these guys on there, like that. Let's set these up. So I guess we'll start just at this end and work our way down. So let's configure this to be transferring into the router. Pop this guy in here and put that one in there. That's already brought those in. Those two, and put that into there. And then we'll turn this all the way up to 16. There you go. Now I just need to put an interface on that and we'll pull it into our system. So this is working a lot quicker than the other step. All right, cool. Yeah, I'll just build the remaining 3. So I'll get to that and come back. All right, I'm back and I've created the other 3, set them up. They are working beautifully. Now, one thing I did have to do, the modular routers were actually too slow, in particular these ones. So it was not able to feed the input bus with the actual ores quickly enough. I had to create some of these speed upgrades. So each of the speed upgrades increases how often it checks for updates. I think 2 ticks, like 0.1 of a second. And so by adding these 4, it takes it down to every 12 ticks that it checks. And that turned out to be just right. Speed upgrades look like this. So it's just some redstone, some gold, blaze rod, gunpowder, and then the blank upgrade, which makes 3. So that's that. I just love watching these blue lines coming out of here. It's like our own little laser light show going on in here. But that officially brings us to the end of the ore processing build. So we can tick both of these off and erase, and we're done. This is how much ore we've actually processed in total, because every single piece of ore produces 1 piece of stone dust. So we're about to get past 5 million ore that's already gone through here. This hasn't been running that long. It's crazy. So the next thing I'm going to do, which I'll do offline, is decommission all of this stuff here. This is no longer needed at all. Each of these towers, and that also means that this is now obsolete. So this wall, I'm going to transfer each of these over to the other wall somehow. And then obviously the last thing is to remove all this. We're not going to have to upgrade our ore processing again, I don't think. We've got loads of resources now. And that brings us to the end of that. Let's have a look at the quest book. Where are we at? So I need to tidy this up. There's a few things I can tidy up there. I'll do that offline. Got that going on. We don't need this stuff yet. We will soon. Don't need the quadria quite yet. This is the next tier of circuits again. I don't think we need that yet. What is going on in ZPM? We probably want the ZPM energy hatch and also the energy converter, obviously. What's involved with this? So first of all, we need a research station, which we do not have. We need to research a LUV energy hatch, produce using a data orb. That gives us that. In the assembly line, to make one of these ZPM energy hatches, we need a ZPM machine hull, vanadium gallium cable, UHPIC chip, ZPM circuit, and a 0-point module voltage coil. Let's have a look. Data orbs. I think I encoded the recipe for that. I did, because that's not too hard. Looks like this. It's just made in the circuit assembler from HV level circuits. So that's not a big deal. So the ZPM machine hull, pretty sure I can make that. So that is there. Yep. Vanadium gallium cable, pretty sure I've got that as well. There you go. Yep. UHPIC chip. Yep. The 0-point module voltage coil. What is this? Made in a ZPM assembler. Magnetic samarium, fine europium wire. Okay, we've got europium, so we can make that. We just don't have a ZPM assembler. So a ZPM assembler would be what here? Elite Assembler 3. Okay, let's encode the recipe for that. So it's going to require us to have gotten to ZPM robot arms and conveyor modules and things. Okay, so let's encode that. And then we need to encode those. These are going to need to be scanned. Yeah, that's what I thought. So it has to be made in the assembly line. So we've got a little bit of scanning to do here. So we've got to scan the robot arm. Probably scan the conveyor module as well, and the piston and all that. All right, so I'm going to need some data sticks. Let's do that. So I'll get one of each of the things we need. So we need a LEV robot arm, conveyor module, probably a pump as well, electric motor. Let's go find the, the scanner, which I think is just down here somewhere. Yep, there it is. Hop her in like that. Just fill this up with data sticks. And just feed these in, I guess. So I'll let that go and come back. In the meantime, we can encode those recipes. What's involved with this? All of that. I'm not checking the numbers here. I really should be. I'm sure that's going to come back to bite me. So just looking through them, there's a few things that we already have, obviously. We're missing some osmiridiums and things. That one's not looking too bad. Same here. Okay. Well, I'll just go through and just make sure all of these are set up correctly, and then I'll figure out what we don't have. Probably mostly osmiridium, right? So like we're going to need screws, rings, plates, probably rods, rounds, the works. Okay. Yeah, I'll do that now. I've encoded all those things. So as you can see, we're looking at the ZPM electric motor. All of those are now craftable. Let's try the electric pump. Okay, I missed that one. The polybenzamidazole fluid pipe. That's not a big deal. This one here, that's all done. This one, yep. And this one. Cool, yeah. I did have to adjust these because the circuits always seem to be incorrect. So it said 111, so I had to change these. So let's go find out how our scanner's doing. It should have done it ages ago. Let's hope it's all... There we go. 5 data sticks ready to go. So we can put them into the assembly line and give it a go. Is there enough slots here? There is just exactly 5. They're all in there, and that means I should be able to put into here these other guys. Right, let's see if we can actually request some of these. Let's try the electric piston. That's looking good. Let's go. No, it's making it. So I was making the motor first. Okay, so that proves those two work. And I guess really, if we make a rubber arm, that's the final step, isn't it? That's cool. All right, we'll let that go. That means we should be able to request that other thing now. This guy. Yeah, well, it's all there. Now, why did we need that again? 0-point module voltage coil. So we should probably encode that recipe. So we've got everything to make this now. And do that. That's good to go. And then that ZPM rubber arm finished being made. Let's make this guy. And does it need a clean room? It does not. One thing we're still missing is the ZPM energy converter, because we can't actually create ZPM power without it. Let's go all the way to 16 amp. So that requires drag and steel wire, ZPM circuits, and a ZPM machine hull. As it turns out, I did peek ahead and noticed that we needed drag and steel. So I have actually been crafting drag and steel in the background because I knew that we're going to need a lot of it. In fact, there's actually a craft going on at the moment because it is very slow. This is the one here, 844 seconds for one craft of it. It produces 14 ingots. So that's probably one of the first things we'll upgrade once we have those energy hatches. But getting ahead of myself, I need to encode those recipes for those drag and steel wires. So I'll do that and come back. And then we can probably make one of those energy converters and then put that assembler in once that's finished. Okay, that's all encoded. There's a lot in that. Look at the chemical formula for that. It's ridiculous. So that means I should be able to put that processing pattern in the assembler once it's built. But first we need that energy converter. So I don't think I made the recipe for that, did I? 16 amp energy converter. Looks like we've got everything for that, which is great. Encode that. That'll do. So let's request one of those. Now what's going on with that assembler? Did that finish and I just didn't notice? Yeah, I guess so. There it is, Elite Assembler 3. Now we're gonna need some drag and steel wire as well to hook this thing up. So I guess I'll just use 2 times wire. That's generally what I've used recently. 32 of that. Oh, there we go, look at that. That's already done. That was quicker than I thought. So we've got that. And get some of that wire. And flux points. And we're good to set this up. Up here would be good, because this is unused currently. Place down the machine. And put the energy converter, I guess, just here like that. Look at that. Elite Assembler 3 running at ZPM. Now we need some of that Applied Energistics magic. Tell that to output upwards. It's building up. I should be able to request one of those in a sec. There we go. There wasn't a program circuit or anything for that, I don't think. Yes, program circuit 1. Glad I checked that. There we go. So that's our first natively ZPM machine. Wow, okay, that's cool. And now, I guess that means we can do this. Ah, no, we can't because we don't have the research station yet. So that is going to be the next step. So I will figure out what that entails and come back. After setting up the macerators and having the system run for a while, it's been running brilliantly, by the way, but look at this wall here. It's basically empty. So this block of 4 machines is keeping up with the entire output of those 4. So that's pretty exciting. So this is mostly empty. Occasionally stuff comes in, but it gets processed very quickly, which is pretty cool. What I've set up over here is a few of these large electrolysis chambers. I use these 2 machines to process some of the intermediate things into their base elements. So for example, chromite. So that's got iron and chromium and oxygen. We don't want to use it as chromite. We want to actually break it down into the individual elements. So that's basically what this is doing. Taking advantage of the master parallel control hatch, running very quickly and spitting out elements like that. Basically cleaning up all the dusts and stuff that come out of here that we can't use. All right, well, I think that's enough of diversion. We need to get back to the energy hatch. So to build the ZPM energy hatch, we're going to need to use a research station. So I guess we should probably get started on that. Yeah, okay. So to get a research station, we're going to need to scan an elite scanner too. We're going to need to build one of those first. Whoa, okay. That's got some interesting things in it. All right, let's go through these one at a time. So the elite scanner, I think that's going to be easy. No problem at all. Data bank requires us to research a data access hatch. It's made of computer casings, data orb, fine cobalt wire, fine copper, indium optical pipe. Computer casing, what's that? Iridium, LUV. That's not a problem. Not going to be quick to make, but that's not too bad. Normal optical pipe. Okay, borosilicate glass fibers. That's something that we didn't make. So I made a decision back in the IV tier here to not do this. I think I made it by hand just to tick it off because we decided that the reinforced epoxy resin sheet would be made quicker and easier with the raw carbon fibers. So I didn't actually do this step. So that is something I'm going to have to rectify because I'm going to need it for these here. This has to be in a clean room. Oh, that's not a big deal. What else do we have here? LEV sensor, obviously not a problem. ZPM, LEV field generator. We just need to scan an IV field generator. Uranium, rhodium dinacridide wire. There's a quirk with that, isn't there? I think we're going to have to go on a side quest for that. I can make the ingots, or can I? I have a feeling I encoded that, but then couldn't make it. Trinium coils. Yep, that's what I thought. We do not have trinium yet. Why couldn't we make trinium coils? Because we don't have trinium yet. We have the trinium sulfide, and we have the ingots. So why can't we make the trinium coils? Ah, here we go, because we needed a ZPM assembler, which, coincidentally, we now have. Let's do that and start crafting those, because that's going to take a little while, I think. Let's encode that recipe for the trinium coil. We've got everything in there. We're missing the machine to do it. Does that make one at a time? Wow, 40 seconds. Yikes. Okay, given how relatively easy it was to make these, in fact, what I'm going to do is I use a trick that I've used before. I'm going to make a second elite assembler and stack it on top. Because that doesn't take very long. And if it's going to take 40 seconds, it's not great. Let's just test. We can make one. Okay, I've got some auto processors that are being a bit annoying here. Oh, here we go. Okay, so that's working. That's good, good, good. Now I'm just going to put a second one on top. That way it can do 2 at once. We're going to have to replace that entire section here. That's going to be 57 times 2. That's a lot. That's a lot of time. One thing about Greg Tech is it's worth building more machines. Always better to build more machines. Otherwise you're waiting for a long time. Case in point, I feel like I need to build a second assembly line because this is a bit of a bottleneck being as fast as it can currently and only having one that's sharing all these recipes. If I split up these, it could be making the electric motors for the next one while it's doing the next thing, which is actually a trick I've used. I haven't shown this off yet. Ignore the second level here. I'm actually... Oh, okay, yeah, I might as well talk about this now while we're waiting. Ah, okay, that's done. Got rid of the door down here because I thought it might be fun if instead of coming in at the bottom level, you come in at the top level. And so I will have machines up here, but for now, I thought this could be the entry instead. And this is a room where you're looking down on the fusion reactor. Oh, hey, guys. Looking down on the fusion reactors. So, because we'll have some more. So it's sort of like, instead of walking in and you're looking up, at the moment you can sort of look down on the things. And there'd be stairs going down. Another way of introducing some elevation to this room by having this kind of almost like a false floor, I guess. What is what I did here as well. This is why this area here is elevated. And I ended up having space to put the ME system underneath. Anyway, getting distracted. Oh, hang on. Getting so distracted, I'm getting distracted from my distractions. So the thing I wanted to say quickly was I did build a second one of these, like a circuit assembler, because they're not too hard to make. And what I've done is I've interleaved the recipes. So this is doing the ZPM and the IV circuits, and the machine downstairs is doing the LUV circuits. So what it means is they can be both running at the same time. This recipe here requires the previous tier, so it can be doing two at once. So it's quicker. I have no problems building more machines if it's going to make it faster. I'd rather burn resources than time. All right, let's put this guy here. It makes this wiring a little bit messy, but go. Tell this to output downwards. So if I queue up 2, it should use both machines. There you go. I could put a third one if I was really keen, which, given how many I'm going to need, maybe I should. Actually, yeah, why not? I could, should I just, I can't do 4 because somewhere I could come out the front. Yeah, okay, let's just go ridiculous. Come on. I mean, this is a very slow process. We're going to need lots of them. Make 2 more of those. Take this cable out the front. You know, absolutely horrific piece of design. So this is like not pretty. I think I might remove it after I finish this big craft. I'll remove like 2 of them because this is not nice. But yeah, do you see what I'm sort of saying? Like by having 4 of them, it's going to increase the throughput a lot, especially for these slow crafts. All right, those 2 are ready. Put that there and put that there. Tell that to go that way. Tell that to go that way. And then I should be able to request a load of these. So it's 57 times 2. Let's just use this, 57 times 2. There we go, 4 running at once. So what that means is now we're doing them every 10 seconds instead of 40. Much better. So in, 240 seconds, I will have enough Trinium Coil blocks to do the upgrade I need to do. We'll go from there. Okay, so we've got all the Trinium coils that have been produced. That didn't take as long as I thought. That speed up that we could achieve with those 4 different assemblers. So I've spent a bit of time creating the to-do list in the clipboard. So this is what I've come up with. So this is our current task. So, create the Trinium coils, which I guess we can tick off. And then we just need to upgrade them, which is the next task, and then craft some of that uranium wire. Broken it down into sort of separate pages because there's like 6 subtasks that we need to get through here. Craft the Elite Scanner 2, scan it to get the research station data stick, make an IV field generator, and then encode the LUV field generator recipe because we need that. We need a process for creating the borosilicate glass fibers and create the optical pipes, the ZPM input bus, and then scan it to get the data stick for the object holder, and we need to get the actual data stick for the data bank itself. So a lot of different steps there. There's probably some I've missed, but that's what we've got ahead of us. Not all of that we'll get through. I think probably we'll just do this and then call it in this episode. We'll see. This is going to be a little bit of a pain to upgrade now because of these extra blocks I put in here, but we'll see how we go, I guess. So there's no crafts going on at the moment, which is good. Get rid of this and get rid of this. Lost a sign over here, I think. Something broke off. All right, now we need to start replacing these. Oh yeah, hazard sign. So we took out that many. We've got 7 spare. That's good. Good news. Well, no, actually, I think I can reach in here. That should be doable. All right, let's do it. That's it. And it's happy. Excellent. Hang on, uranium, rhodium. So there's 3 inputs. So that'd be program circuit 13. Program circuit 13, I think, is this one. Yep, here we go. Cool. All right, let's craft one of those. Missing uranium dust. Okay. Is that because of this process over here? Have I been converting all my uranium? I think I have been. Is that over here? Yes. All right, so let's cancel that. Hopefully that will replenish quickly enough. Oh, there we go. It's coming back. All right, cool. So I should be able to craft one of those because it only uses 1 dust. Should be going here. Oh, it is. Look at that. 19 seconds. I realized something here that I didn't initially. The LUV 16 amp hatch takes it up to UV power, but is only LUV recipe tier. I was trying to make dragon steel. Very slow process. The molten dragon steel recipe requires a ZPM alloy blast melter. So that's obviously a problem, because if you put one of these 16 amp hatches on there, it stays at LUV recipe tier, but upgrades the power tier to UV. So what I'd done was just use 2 normal energy hatches. And as we know, that will actually increase the recipe tier. But then I realized, if you take 2 16 amp hatches, you can achieve the same effect. So what I've done is upgraded this one here, and it is actually ZPM recipe tier, but UV power tier. It's like these ones, like just as fast, but can do 1 recipe tier higher. And as it turns out, I needed that for dragon steel. But I think also, from the looks of that uranium one, I think I needed it for that as well. So that's quite convenient. Obviously, it uses a ton more power now. Okay, yeah, this is what I thought. I haven't set up the recipe in the vacuum freezer to cool that molten uranium yet. I'll deal with that in a sec. But actually, no. So the uranium rhodium dinacridide is only IV recipe tier. That's right. Okay, let's find one of our things here. This will do. That one. Hopefully that. Yep, there we go. Brilliant. I like it when things just work like that. That is very exciting because we now have that, but we do need to create that wire. So there's recipes I need to encode for that. Yeah, this one. 2 times uranium rhodium dinacridide wire. Let's do that. Done. So that's one more thing we've ticked off. Cool. All right. That is good news. Yeah, I guess the next step is going to be to make the elite scanner too. So what's involved with that? All those components. Oh, we can request that. Let's do that. Just need that LEV sensor. Once that's finished, there we go. Pop that in there. Take the elite scanner. Cool. So this is the scanner. So I guess we can use the elite scanner to scan the elite scanner too. I had an interesting problem happen here. Remember I set up that hopper? This extended pattern provider saw the hopper as a valid target for putting its ingredients. This macerator was starting to put things into the hopper that would go feed them into this machine and obviously not work. So I had to take it out. So that's something that we'll use if we need to do some bulk scanning, I guess. But I guess I can put that in there and do that. Nice. I'll leave those in there because we're going to need them in the future. So that's a slow process, 120 seconds. So we'll come back to that. Tick this off. Cool. All right, well, we're making good progress. Another thing we need to do is make one of those IV field generators so we can scan it to get the LUV field generator. Cool. Let's craft one of those. And then we can go and scan that over here. How's this going? Ah, it's finished. Cool. Got the research station. IV field generator in there. Nice. So research station, LEV field generator. That's one thing we need. We've got the ZPM circuits. We've got the ZPM electric motors. We've got that wire. Trinium foil we can do. Can't do the optical pipe yet. So let's move that over there. That's still to be done. And the data bank. Everything else I think is covered. Yeah, so it's just those 2. Let's grab that. And we got those 2 data sticks. Okay, so now we've got a small problem in that the assembly line does not have enough data access hatch slots free. We can only have one of these on a machine, and I can't yet build the larger one. I may have to build another one of these. But for the moment, we'll do that long term because we're going to need more than one. But what we can do is swap one of these out. So I guess we don't need the fusion reactor at the moment. We can pop that in. And then if I encode the recipe for the LUV field generator, should be able to make that, right? Is there anything special in that we are not going to be able to make? The LUV field generator, that should be doable. So I've got to pop that into the assembly line over here, and I'll see if I can make one. Looks good. It's going to take a little while to put that together. So while that's happening, I might as well have a quick look at this data bank. So I do need to scan a data access hatch. Put this in here. So we'll scan that, and we'll get the recipe for the data bank, and the data bank itself requires these. I think we have all of that, except the optical pipe, and that's basically the next step. Got the data bank. Over here and do another swap. What are we going to take out? Maybe I'll take the energy hatch out because I know other things don't rely on it. And we'll swap in the data bank. Cool. All right, so that's the next step. Let's get the optical pipe. So we're going to need the borosilicate glass fibers. And I think I've discovered that it's actually not too hard to make, which is good. Normal optical pipe is just borosilicate glass fibers, silver foil, and liquid polytetrafluoroethylene in an assembler in the clean room. So let's encode that recipe. That shouldn't be too much of a big drama. I think those numbers were correct. Hoping they are. It's in here. Pop that in there. And then we just need the borosilicate glass fibers. That's made from a borosilicate glass bar in an extruder or a wire mill. I think we'll go the wire mill. That's pretty much a lot easier. I think we need to use the fluid solidifier to make the solid bar from the liquid. So let's do that. Question becomes, how do we make the liquid? We just do this in the alloy blast melter, program second 8. It's very quick. LV, 7.5 seconds. Glass, boron, done. I don't have any of these that are on program second 8. But this one, I think, is not in use. No, it's not. So I can just change this to 8. Not being used or anything. Pop this into there. Request some of those. So it made the liquid very quickly. Something's still going on. Okay, hang on. Oh, wait a second. It's probably stuck in the machine. I don't think there's a way for liquids to come out of there. What's that? That is a storage bus. Fluid solidifier is over here. Why can't that grab it? I would have thought that would have worked. All right, let's just do it manually, see what happens. Yeah, that worked. Okay. Maybe the numbers are wrong. All right, I'm going to have to debug that and come back, I think. I figured it out. I'm sure I've done this before elsewhere, but the crafting system couldn't deal with the fact that this was a storage bus. So it was creating the liquid glass in here, but it wasn't unable to extract it as part of the crafting process to go into that machine there. So changing it to an interface means it imports it into the system, obviously, once it's finished. And that works. So if I make, say, 32 of this, you can see it's firing up over there. And now it's done. I think I can probably make those fiber pipes now. Let's give that a go. 16, let's see how that works. That should be happy. It's not the fastest machine, is it? Takes a little while. 3 seconds per craft. Okay. All right, cool. That's that done. Guess that means we can now request a data bank. Oh, wow, we can. All right, let's do that. Cool. Data bank is done. Alrighty. Now, that means the research station. I think we can encode this recipe and request one. 8.2, 232, 32, 16. 232, 32, 16. All right, cool. Let's grab that. And let's go make ourselves a research station. It's exciting. Quite a complicated craft. A lot of components going into that. Doing another craft here is probably one of the LUV sensors. So that's the last piece. It's very exciting. Okay. Right. So there's something's gone wrong with the recipe, which I expected. I must have counted wrong somewhere. So we've got a data bank, LUV sensor 8. Then it's 8 crystal processor supercomputers. Yep. Then it's 2 LUV field generators. 2 ZPM electric motors. Oh, hang on. Nope. I just realized what it is. It has to be ZPM. So this is only currently LUV because I need to do the same sort of thing here. So I need a second LUV 16 amp energy hatch. Luckily, I've got one of those. Take this out of here. That's the problem. I mean, okay. That's quite funny. I didn't expect that to start. Well, I mean, yeah. So by the rules of the game, that's upgraded that to ZPM. So now it can craft it, even though I'm not providing any power to it. It did it. Cool. Let me just quickly just fix this. I'll do that. Put that guy on there. Hook that up like this. Cool. All right. That will work. It's not pretty. I'll fix that later. We now have a research station. Look at that. Let's take these off. And that. Right. Okay. That is a major achievement, and I think that's a good place to stop. What I'll do is I'll gather the components necessary to make that, because the research station itself, it's a multi-block with a bunch of things. So computer vents. Oh, a lot of lag there. Something about rendering that is slowing this down a lot. Anyway, well, I need to build those things. I think we'll tackle that next episode. We'll start fresh, and then we can just dive straight into the research station. And the other thing is, I don't actually have a spot to put it yet. So I am in the process of extending this area out here, extended the stairs. I'm still figuring out how it's going to look. But I want the research station to sort of sit flush with the floor so that it's not kind of sticking up. So anyway, you'll see that when I get to it. We got a lot done today. We finished the ore processing setup, which was pretty good. Even if it was actually finished last episode, but there wasn't time to include it. But we have definitely started ZPM. That's a fact, because we've powered a ZPM device with that assembler. So that's pretty exciting. And obviously, yeah, we've upgraded to those Trinium Coils, and we're well on the way to building that research station. So that should be pretty much first up next episode, which is pretty exciting. Thanks for watching, and I look forward to seeing you in the next episode. Cheers.